Okay, let's get started. So, are there any questions? What's due today? Any questions? Yeah.
Does auto take up more memory than specifying whatever you tell it?
So, does auto take up more memory? So, it depends. Very likely not, because what we've been doing so far is we figure out what the type is on the right side, and we put the exact same type on the left side. So putting auto there won't actually change anything. But some weird examples where you put something on the right and you put something different on the left, and it's okay for some reason, then it may cause an issue. In the sense that auto will maybe use more memory. But for what you've seen so far, it will never increase the amount of, it won't increase the executable file. But if you're having like an int, if you have an integer, so that's 3 characters, and if you want to put auto there, then that's 4. So auto is really only good for like using string or double or something like that, because those are longer names. But yeah, I don't think it uses more memory though. Yeah.
So, for example, if you wanted to use a number that was a floating point and you used auto, would it automatically use whichever one is like the one that needs like float or double?
Oh, that's a great question. I do not know. I think if it depends on what you write on the right side. So if you put, say, 4.0, exactly that, then it'll default to double. If you put 4.0f on the right side, so the f is different, it will be a float now. So if it has nothing else to go by, it'll default to double.
But a float takes up less memory, right, than a double.
Yeah, but here's the thing. The executable will say, I want you to allocate 4 or 8 bytes or whatever for a float or a double. It doesn't actually take up that space in the executable itself. It may write a 4 or an 8, but those are 1 character each anyway, so it doesn't actually matter here. So in this case, I don't think you will go wrong in using doubles everywhere, but put auto on the left side. Other questions? Cool, and assignment 6 will be out hopefully pretty soon. I'm just waiting for the test cases now. Okay, so last time what were we talking about? Still talking about objects, unfortunately. Well, what things did we talk about last time with respect to objects?
Include guard.
Yeah, we talked briefly about the include guard. So what was the purpose of include guard? Yeah.
Like maybe the head separate.
So we talked about putting headers and implementations in separate files, but what does the include guard do that can potentially help us?
Prevents different header, like different parts of the header files to be used twice. So
Right.
if the string is located in 2 separate libraries, it's not going to be loaded.
Right. So the purpose of include guard is if you want to include some header like string or IOStream or whatever, it will only be included once. So if you have the include guard there. So if you put the include guard in our circle class, then if I include the circle class over here and over here, it'll only be included once. So it's good in that respect. What else did we talk about?
Objects, messing objects.
Yeah, so just basic stuff about objects. You can pass objects to functions either by value or by reference. What does this const on the end of the function getSide here mean? So we talked about this last time. What does the const mean on the right side? Be more specific. Yeah.
Is there not going to be a set side class?
Oh. No, there is a set side function. So the set side function does stuff. Sorry. There's a get side function. Set side is independent of this. So what does the const mean here?
Use const to set getters, not to edit data.
Right. So the function get side here, because we said const on the right side, that means that nothing inside the class is going to change when I call this function get side. It may give us a value that's internal to the class, but it's not going to change any value. So our get radius function from our circle class, it just returned the internal variable radius. If it just returns a variable, does it change the value of the variable? No. So for that reason, we can set it to be const. What about the set radius or set side function? Could we declare them const? No. Why? Because it does an assignment to an internal variable. Something of the class actually changes. So whenever you see a const on the right side of a function and wonder, okay, what in the world is that doing there? It means that nothing in that function changes anything inside the class. So the object has the exact same state before and after you call the function, which is pretty nice to know. Okay, so we talked about some other things like returning objects, composition, which is we have objects inside other objects. Nothing complicated there. Okay, so I think we were here. So let's wrap up objects today, hopefully. So we talked about this before. This is just basically a small review. We can declare a function inside a class or outside a class. So inside the class, remember, they're called inline functions. So they're inside the class. Inline, same thing. Outside the class, if we want to declare a function that belongs to a class outside of that class, what else do we need to do to the function to say it belongs to this class? Say the circle class. Right, yeah. So we need to say before the function name, the name of the class that it belongs to with 2 colons to say this function get radius or whatever belongs to the circle class. And so it's not just a free function that anyone can call. It belongs to the circle class. So if you have a circle object, I can call that function because it belongs to the class. So we've talked about that before. Okay, so I'm going to only briefly go over like the next 10 slides or so. So I'm put these in here because if you're going to be reading C++ code, how many of you have seen struct before? So a few of you. If you've looked online, you say, okay, I see this struct thing. I don't know what it is, but it kind of looks like a class. So what is it? So a structure is literally identical to a class, except for one aspect, other than the name. So you can have fields in here, you can have constructors in here, you can have destructors in here, you can have functions. Anything that a class can do, a struct can do, and vice versa. They're exactly the same. The only difference between them is what is a class's visibility by default? It's private by default. What do you think a struct is by default? It's public by default. So that's the only difference between a struct and a class. So a class is private by default, but you can make things public if you want. And struct is public by default, but you can make things private if you want. So if you have a class over here, I can convert it easily to a struct, and vice versa. So as long as I put the appropriate visibility modifier in the right places. But there's really no difference otherwise. So I can make structs in exactly the same way. Note, are all these 4 variables right here public or private? Public, because there's no modifier saying they're private. They're public by default. So you may think, okay, well, why do we have structs and why do we have classes if they pretty much do the exact same thing other than this small modification? So it goes back to the name of the language, C++. So structs actually come from the language called C, which came from before C++, as you might expect. So structs come from that language, but they don't have constructors, destructors, anything. They just have these fields in here. So when C++ came along, they said, okay, well, we should update this so that we could put functions and constructors and destructors inside structs. But then other languages came along, like Java, and among others, where they have a class's structure being private by default. And people are much more used to using class something versus struct something. So I guess what they decided to do was to make a new structure called a class and have it the exact same behavior pretty much, but have it be called class to try to bridge the gap in trying to understand C++. Because if they see the word class, they know what that means. But if they see the word struct, you might not know what that means. So that's my hypothesis as to why this is here. So I'm not going to actually test you on this, on structs or anything, other than like the difference between struct and class. One is private, one is public by default. But they're just here for your benefit. So just if you see structs somewhere, just note that they're exactly identical to classes other than that one change. Okay, and I won't go into initialization lists because they have to do with structs, and you can use them with classes too, so it doesn't actually matter here. Okay, so let's wrap up the last slides on objects. So these are just high-level things that you kind of hear in keynotes, nothing of actual substance, but are actually useful in some cases for understanding how to use objects. So object-oriented analysis is you have a set of requirements given to you by your boss or whatever, and you have to figure out, okay, I have these objects here. How should I design the objects? So if I'm instructed to make a bunch of circles, how should I make my circle class? So what function should I allow the user to use? Should I have a getRadius function? Should I have a getArea function? Are these things actually necessary? So what you need to figure out is from the requirements, what classes do you need at all, first of all? For each of them, what should they have? So what attributes should they have? How should they behave? Which means what function should they have? And how should classes relate to each other? So should I, if I'm making a bunch of shapes, for example, should I have like a circle, square, a rectangle work independently? Or should I have, for example, a square have a lot of the same code that rectangle does? Does that make sense to have a square have the same code pretty much as a rectangle? Yeah, because all squares are rectangles. Are all rectangles squares? No. So there's kind of a one-way relationship between a rectangle and a square. What about between a circle and a rectangle, for example? Should there be a link between them? Maybe there is, but it doesn't appear like there would be. So you need to figure out, okay, there's this one-way relationship here, and there's a no relationship here. What about a course object and a student object? So can a course have many students? Yeah. Can a student have many courses? Yes. So there could be a many-to-many relationship between objects, which is possible. So you got to think about this, about like how should you design the objects versus how they should relate to each other. So how do you figure out what objects to make? This goes kind of from experience, so you kind of have to get the feel of doing this. But some good ideas are if you have some component of a system, have that be an object. So like for the shapes that we were working with, a circle is one of those components of the system. If you're working with some UI stuff, so like a text box, for example, that is a single component, have that be an object. Or if you're getting things from a file, for example, or maybe you're writing a handler for parsing input from a file, have that be an object. So either like one component or one function, not in the sense we know functions, but like one functionality that has to be performed, have that be an object and wrap it up in a class or a struct. Physical objects, historical data, yeah, all this kind of stuff. So if it's like one big entity, have that be a single object. But again, it comes from experience. And then you have to figure out, am I going too deep into the weeds here? Am I making an object for something that's kind of trivial? Or am I making an object for the entire thing and I'm having to manage each little piece versus going in the middle ground and saying this semi-large component and this one together can be used as separate objects to make one big object. So you got to think about how to actually make your objects be useful. So not too detailed, but not too high level either. Yeah, so attributes are how the object holds certain data. So like for a student here at ASU, you would want obviously a name, a GPA, student ID. So obvious things like that should be attributes. We've kind of talked about that already. Yeah, so attributes are what is necessary for the object to do what it's supposed to do. So like for the circle, for example, is the radius necessary? Yes. Is the color necessary? It depends. So in some cases, if we're just working with the shape itself and nothing else, yeah, it's not necessary. But if we're designed with printing a circle with some UI component, then it is useful. The radius is always useful, but the color sometimes is useful. So again, you have to think about what is actually necessary. Has anyone heard of MVP? Not most valuable person, but for software? It's sometimes called minimum viable product. So do what is absolutely minimum to get the object to do what it's supposed to do, and then ship it. So don't put unnecessary stuff because now you're wasting time doing things that are not necessary. Yeah, so behaviors, which are the functions we define on the class, determine some of the member functions of the class. So the behavior here means what does the user see of the object, i.e. the public functions, not the private ones. So when it says some of the member functions here, that means the public ones. You could have some private functions where you have some behavior that does some important work that you don't want the user to see, then that would be a use for a private function. So again, it depends what the use case actually is here. So how do you actually figure out, okay, we've figured out what the classes are, how do we relate them to each other? So there are 3 different types of relationships here. So the one that you're going to be using most often is the second one, which is the HAZA one. So think about like the circle class we've made. And let's just say the color is necessary, that we did use it. Well, the string is in fact an object. So the circle class has a string inside of it, right? Does a string have a circle inside of it? The other way around. Does a string have a circle? No, because a string just holds the characters. It doesn't know what a circle is, but a circle, in our case, holds a string. So that's the case of has a relationship. Uses a means you're not holding the data member like the string as a data member, but you're using it somewhere in the class. So like in a function, for example, maybe you want to convert the radius to a string. So from a double to a string and return the string. So that function uses a string, but you don't have a string as a data member. Okay? So uses usually comes from using the object inside a function. Has corresponds to having the object as an actual data member inside the class. So the object is holding that piece of data. So the third one here is we haven't gotten to yet. But think about the rectangle and square example here that I came up with. Is a square a rectangle? Yes. So every square is a rectangle. So that would be a case of an inheritance relationship. But think about this. Does a square have a rectangle? So does a square, other than the side length itself, does it hold a rectangle object, or should it hold a rectangle object? It could, but does that actually make sense though? Well, we've already defined the is a relationship between them. It doesn't make sense that the rectangle is being held by a square. So we'll talk about inheritance when we get there. But it's where something is something else, but it's not actually holding that other thing. So a square doesn't hold a rectangle, but it is a rectangle. But we'll get there when we get there. Any questions about the relationships or anything else? Okay. So this is kind of not that important. So you have to also figure out what is the class supposed to do. What is the class responsible to know? So think about a student. Are there some things that the student object shouldn't hold itself? Well, maybe some identifying information about that student that could be compromising if someone broke into the student object. So maybe like the social security number. So should a student object know the social security number of that student? Maybe, but it depends on how it's actually being stored. So you have to think, what should the class actually know? So it goes back to what we were talking about before. What is the minimum necessary information for a class to function properly? You also have to think about what should the class actually know? So other than just the necessary stuff, should it know anything else? Or is any of this stuff that we thought was necessary, we should put somewhere else and have it not be stored in a student object, for example? Or should we hold them as data members, or should we have them be functions? So think of the circle. Does it make sense to hold the radius and the area at the same time? Probably not, because one dictates the other. So if I know the radius, I know the area. If I know the area, I know the radius. So if I update the radius somewhere, I have to update the area at the same time, because they have to be in sync with each other. So that would be a case of where we define one of them as a function, so that the circle class shouldn't have to know the radius and the area, because from one I can always find out what the other one is. So that's why we made the getArea function, because we don't want to have to store the area in addition. And this, I think this, let's see, two more. So reuse just means reuse objects if you can. So don't reinvent the wheel is another way to summarize this slide. And I'm not going to actually test you on this one either. But sometimes you have functions that are more object-oriented than other programs. So if you're using a lot of objects, then it's more object-based than an object-oriented program. So this is not actually that important, but you may see the terms object-based and object-oriented sometime. I have never seen it myself, so let's skip that. Any questions about objects? Cool, we can get on to the actual interesting stuff. So let's talk about something that actually makes our programs really useful now. So for assignment 4, so let's try to, I know you want to forget assignment 4 by now, but a lot of you wrote a bunch of variables out. So you wrote like 32 variables out. And that was actually one good way to approach it because we haven't talked about this. But what if I told you, put that meme on from the Matrix, what if I told you that you can wrap those 32 objects into 2 objects? Wouldn't that be a lot easier? What if I said, instead of having, let's just say I was making a, like I was grading your test for something, and I wanted to record all of your test scores into some structure. Well, I could make 70 objects. There are 70 of you still enrolled. So I could make 70 individual objects, or what I could do now with what we're going to talk about is I can make 1 object and then have all 70 of those objects be wrapped up into 1 gigantic object. So wouldn't that be a lot easier to work with? So that's what an array actually is. So an array is just a bunch of variables of the same type. So it's just 1 object in some sense that stores a bunch of objects of whatever type you want. So look at the example down here. So this array, I'll talk about the notation in a second, is going to have 5 integers in here. So the thing between the brackets is telling the C++ how many elements we want in our array. So in this case, we have I size equal to 5. So that means we're going to have 5 integers in this array. And the type on the left here signifies what types are going to be stored inside this array. So if I change this to be string, for example, so what can you tell me about the tests array now? Yeah. Yeah, it's going to have 5 strings. So as long as I specify the size of the array and the type of the array, now I can store as many objects of any type that I want. So here I could say 10,000, and so now I have an array of 10,000 strings. Aren't these really powerful? Isn't that awesome? So I'm super giddy about that. So can't you tell? So what you may be wondering what these square bracket operators are for. So the square bracket operators are a way of communicating this is an array. So whereas before we would say string tests like this and nothing else, maybe set it equal to some string, I don't know. But if you want to actually declare an array, you say the name of the array, test in this case, then square brackets. Then inside the square brackets, you say how many integers or how many strings you want in the array. So in this case, I'm going to have 10,000 elements. 10,000 strings in this case. So, yeah, go ahead.
Can't you just like forget that first line and put the 10,000 right where it says I size?
Yes. Yeah, so the question is, can I just put the 10,000 right inside the square brackets? Absolutely. So I can do that, and it'll work just fine. Yeah. So the reason why we declare sometimes a constant integer to be the size of the array beforehand will become evident really shortly. But suppose I want to iterate over the tests array. There is no way, well, there is, but there's no easy way of determining the size of the array from the array itself. So just knowing the tests array and nothing else, you could figure out the size of the array, but it's kind of cumbersome to do so. By saying the size beforehand, now I know exactly what the size is. So the about the array itself, and we'll do an example of this, the values of the array are stored in consecutive memory locations. So it's just a giant contiguous block of memory. So I should convert it back to integer for reasons we'll eventually get to. So I'm going to convert it back to int. So suppose int has 4 bytes. So if int has 4 bytes, how many bytes in this case does the tests array have? Well, there are 10,000 elements in the array, and each of them has 4 bytes. How many in total? 40,000, yeah. So so I converted it from string to int because string is a little more complicated to explain that concept. But int is really easy, so I went with int. So if you have int, and let's just say 4 bytes, times the number of elements in that array, which is 10,000 here, that's the number of bytes in the array. Any questions about arrays so far? Okay, so this is just a pretty picture representation of what we just said. I'll go over the 0 in a second, and why that is. So I said that arrays are in contiguous blocks, and let's just say we converted I size back to 5 to be easy, to make it easier. So there are going to be 5 blocks of memory. Each one of them is going to hold a single integer. So the first block is the first integer, second block is the second integer, third, fourth, and fifth integer. It may seem like I'm pulling teeth at this point, but it's important. Anyone know why it says 0 here?
Was it just because like you start counting from 0?
So I don't know who did this, but they must have obviously fell down and hit their head, because I don't know why counting starts from 0. Actually, I do know why, but it's actually a complicated reason and a long story. But there's a fundamental disconnect between actually implementing arrays versus actually using arrays and actually reading papers and implementing algorithms, because a lot of papers have their indices starting at 1, whereas real arrays, if you want to actually implement them, start at 0. So you may now know what the biggest security vulnerability is in all of computer science, and off by 1 error. So what will happen is, suppose I implemented an algorithm incorrectly, and I say, I'm going to go through the tests array, starting at 0, so I'm being good, I start at 0, and going up to and including the length of the array. What is the length of the test array in this case? 5. I'm going to look up element 0, 1, 2, 3, 4, and 5. Is element 5 in this array? No, it's the 6th element of the array. Well, it would be the 6th element of the array. It turns out that C++ will not crash or anything if you go past the end of the array. So what will happen is, if I write my loop incorrectly, I may go into memory that's being used by other applications. So you may now know that it's a huge security vulnerability because I can just plow through the other contents of the memory, print them out, and now if like your password is stored in the memory, I know your password now. Pretty interesting. So there is a mechanism to get around this. So I actually would advise you not to use arrays, even though I'm covering arrays, because we're going to talk about something that is an object wrapper for an array that does the bounds checking. So if you do go beyond the bounds for whatever reason, it will make your program stop because throw an exception is what it's called. It'll make your program stop because you tried to do something bad. And there are other reasons why you would want to do that. But the thing is, you're going to see what are called native arrays, which are these things, these square bracket arrays like this, all over the place. And so there are very, very few cases where you should use an array instead of the concept we'll eventually talk about. So this is just an educational thing, just to get you to know, okay, arrays have existed and you will see them, but there's a better concept. But you can see why arrays are problematic, because if you want to loop over the array, you could go do something that's not a good idea. Okay, so let's get into more things about arrays. So the thing on the left is just what types are in the array. So what is the type of this array? Int. Yeah, so it's mainly just what things can go in the array. Name of the array is tests, obviously. I won't actually test you on this because I've never actually seen this term used, but the size declarator is the number of elements in the array. We just say the size of the array or the length of the array. They mean the same thing. Yeah. Although some people do say the size of the array is the number of bytes in it. So I'll use them interchangeably between size and length because we're not going to actually care about the size of the array for what we're going to do. But sometimes you actually do care what the size of the array is. But we're not going to worry about that. So here are just some more examples. So I could have an integer tests array right here, which has how many elements for the tests array? 5 in this case. How many doubles does the volume array have? 10, which is just the number of things here. One of the important things about arrays are, suppose that we're looking at this array right here, and suppose that a different application, a completely different application, is using the memory location right after where the array is. So from that, do you think arrays should be allowed to grow in size right in where they are? Well, if I have, like, say, a 10 element array like this, and there was some functionality to extend it by 1 or something, then I may impede on some other application and then use their memory when I'm not supposed to. So arrays don't have any functionality at all to resize to a larger array, unfortunately. There's a way around this. But for what we need to know for right now is you make the array as big as you need to right up front, and then you just use the array as is. Again, there is a way around it.
So it would give an error if we did isize plus plus?
No, it will give you an error, but for a different reason. So isize, remember, is just an integer. It doesn't dictate anything other than what the size of the array is. It doesn't have anything in connection to the array. So it's not like if I increase the size, then the array increases in size, because it's just an integer. It will give you an error because it's a const integer.
Okay,
So
if it wasn't a constant and we set like for like a loop, so we had like cin for isize, and we had like isize plus plus to like add another block to the array.
That's actually a much better question than what than you may anticipate.
Okay.
Oh, so it depends on what you mean by in a loop. So are you declaring the array inside the loop, or is it before the loop? It's a very important question, actually.
I guess it would be declared before the loop.
Yeah, okay, before the loop. So the array will stay exactly the same. It won't actually change. If you declared it inside the loop, I don't know. So if you have like the I size change, so like you do I size plus plus in the loop and then immediately declare the array right after it to be that modified size, I don't know what actually would happen. So what would be a way that I can test what actually happens? Test it. So let's see. Let's just make a simple loop. I size equals. So I better make this a non-const integer because I'm modifying it. So I size, let's just do less than or equal to 10. I size plus plus. And then let's make an integer array I size like this. And so I'm not going to actually do anything useful with this. So let's actually just see if this even compiles. And I'm not even sure if it does. Oh, it does. So consider this. So let's just take an integer n and cin the integer n from the user, okay? And I'm going to have I size go up to n this time. This will probably compile, but oh, yeah, it compiles. But consider this now. What if I declared an array of size n in this case? Of course it compiles. Yeah, that shouldn't compile.
Why wouldn't it though? Because
So
you're inputting so n has a declaration before the arrays.
right. So this goes back to, yeah, I'm not sure why that is. There's a very good reason for this, I'm very sure. So the reason why we have like an integer like this, 5, that's known beforehand, is that arrays need to know when you're compiling how many bytes they're going to hold. Let's see. Yeah, they need to know precisely how many bytes are going to be allocated. Versus if you're taking an integer from the user, it doesn't know precisely the number of bytes that are going to be formed from the array, because the user could enter 100 or 10 million. It doesn't know precisely the number of bytes. Because in the executable, when I do this, when I have an integer array like this, and let's just say it has 5 elements, it says allocate 20 bytes. So arrays aren't actually anything other than just a contiguous chunk of bytes in memory. So it says 20 bytes of memory are going to be allocated. Whereas here, it doesn't actually do that. So I'm going to actually show you a tool that could actually be useful in some cases. How many of you heard of Godbolt? So it's great. So go to gcc.godbolt.org, and it's something called the Compiler Explorer. So what we have here is it'll actually have, if you put the C++ source code on the left side, it will give you what is the actual assembly, which is the executable code that's generated. And if you provide arguments up here to say, I'm going to actually have this compiler flag or anything else I want to do specially, then it'll tell you if there's a compile error, and if there isn't one, what is the actual executable that's generated. So you can actually see what is actually being executed on the real hardware. So if we actually try to compile this, I'm not sure why that is. So this should actually give a compile error, and I'm not sure why. Let me try something. Let's see. Yeah, of course that compiles, even though I expected it to not compile. So I will look into this. So the reason why I expected it to not be is that n is not known in advance to be, the value is not known in advance. Yeah, so I'm not sure why that is. Okay, let's see. So we got like 4 minutes, plenty of time. Suppose that now we've declared an array. Now we want to get access to the stuff on the inside. We want to actually change the elements of the array, or we want to get the elements out of the array. So how do you actually do that? It's really, really, really simple. So after the array has been declared, then what you do after is the same square brackets on the name as before, and then you put the element what is called index. So remember the 5-element array we had? What are the element indices starting at what? 0, and it went up to and including 4. So in that case, if I put 0 here, that's accessing the 0th element of the array, which is the first position in the array. So index 0. So let's just say the entire array was zeros beforehand. After I do this first line, what are the contents of the array?
First one's 79, the rest are 0.
Right, first is 79, all the rest are zeros. So the first one gets modified, and the other 4 are not modified. Cout test 0 would obviously print 79. The cool thing here is that the square bracket is used both for setting the value and getting the value. So there's not a setter and a getter here, which is pretty cool. So if I wanted to set tests of 0, then I just put it on the left side of the equal sign. If I want to get the values tests of 0, then either on the right side of the equal sign, or put it in like a cout expression, cn, whatever. So I can use the same expression to denote getting the value and setting the value, which is nice. So tests of 0 would print 79 here. Let's say that tests of 1, right here, this cn statement, the user enters 10 as an example. What will tests 4 be? So what was tests of 0 right now? 79 still. What is tests of 1 now? 10. So tests of 4 now will be 89, because it looks up the value in the 0th index and the value in the 1th index, first index. Then it adds them together and sets the 4th index. So it looks up 79 and 10, sets 89 to the 4th index. So if we looked at the array right now, after those 4 lines, we have 79, 10, what comes next? 0, 0, 89. Because there are two indices 2 and 3 were not ever set. So they are 0. This is something that we won't actually talk about. So if you wanted to print the array, you can't just do this, unfortunately. You can't just print out the tests, because it turns out that arrays are a generalization of something we'll talk about later, and tests is just actually a memory address. So the word tests itself is just a memory address. And the 0s, 1s, and 4s are just telling you how far away from that address to go to find the value you want. So if you try to print tests here, it'll print some long random number, and that will be the actual address of where test is. So if you wanted to print the array, you'll have to do something different than that. Yeah, so we can see into a particular location. So we just went over that. Subscripts. So subscripts are the thing between the square brackets. So subscripts just means the index of the array we're looking up. So the first one is we're looking up index 3. Second one, we're looking up index I. Third one, we're looking up index I plus j. And accessing all elements, we'll talk about next time.